Hi everyone. In this video I will be demonstrating how you can use Andrew Hayes process macro with RStudio to test a simple mediation model. And before we get started, there are a few things that you will need to have in order to follow along with the video. So first off, you need to have a copy of RStudio already installed, so make sure that you've done that. Secondly, you will need to have a copy of the R file containing the process macro, and you can obtain a copy of this by going to Hayes website and downloading a zip folder that contains the process macro, and there are several different versions within that folder, and within that contains the R file script. Just to show you what I'm talking about, if we go to this website right here and we're under the downloads folder, if you scroll down to the bottom, you'll see it says download process version 4.1. So when you do that, you'll have this zip folder that is downloaded to your computer. And I'll show you what it looks like. Here's my downloads folder, and you can see that we have in the folder, we've got a little zip file down here. It says process 4.1 right there. If we double click on it, you'll see that there are several subfolders, if you will. One of them is process 4.1 for R. Double click on that, and here is our R file. So that's how we're going to be working with that particular script. Okay, and the last thing that we're going to have is a copy of the raw data file, which you can obtain by following the link that is provided underneath the video description. Just so you know, our raw data is in a text file, and I'll show you how to import that into RStudio as well. So in this video, I will be showing you how to activate the process macro in RStudio. We'll import the raw data file into RStudio for our analysis, and we'll be covering commands for performing a basic mediation model. So the model that we're going to be working with looks like this. Basically, we have three variables in this system. We have student interest, which is our X variable. We have engagement, which is our M variable, and achievement, which is our Y variable. And so all three of these variables are quantitative variables in our data set. And we have three paths that are being estimated, A, B, and C prime. The indirect effect of interest on achievement through the engagement variable, our proposed mediator, is quantified as the product of A and B, and then we can test that for significance, basically kind of testing whether the indirect effect is non-zero. This particular model 2 is comprised of two submodels. You could kind of think about them as submodels. Model 1 is essentially a simple regression model where we have engagement regressed onto student interest, and that's used to estimate path A. And then we have a multiple regression for our second model where achievement is regressed onto interest and engagement, and this is where we are going to be estimating path B right there, as well as C prime right here. So those are the regression submodels. Okay, so now we want to go back into our folder, and remember what I said before. When you downloaded process, you'll see that there is that zip folder I was telling you about. So when you click in there, and you'll have your process 4.1 for R, double click on that, and inside that you have this process R file. So if what we'll do is we'll double click on that file, and then RStudio opens up, and you'll see that if we kind of move this down just a bit here, you can see that the macro, the syntax for the macro, is given in this top pane. And so what we need to do when we are running our analysis using this macro, any analysis, we're going to have to activate this macro first. So if I tried to go ahead and start typing in commands at this point, I would end up with an error message because the macro is not activated in memory. So this is following the same principle. If you have any familiarity with using Hayes process macro script with SPSS, you'll know that you have to activate it first before you can use it. So to do this, we're going to go back up to the top pane, and we're going to select all. and then we will press the run button. So it takes a couple of minutes to activate the macro, so you just kind of have to be patient. So I'm going to pause this just briefly and let this kind of finish carrying out, and then we'll move to our next step. Okay, so after the script has finished processing, you'll see at the very bottom in our terminal here, you can just kind of scroll down, you can see all of the code. So make sure that you go to the very bottom and you'll see it says process for R version 4.1.1, and it says process is now ready for use. So we're just about where we need to be, but the next step is we need to import our data into RStudio. So the data that we are working from is basically in this text document right here. So again, you can access this, you can download it to your folder by just following the link that's provided underneath the video description, or download it to your computer, that is, using that link. So this is just briefly kind of what it looks like right here. So you can see we've got the variable names at the top, and then we got our data. Doesn't look very pretty right now, but that's what it looks like. So now we're basically, what we want to do is we want to import this data set. So to do that, we're going to go to File, Import Data Set, and you'll see that we have from text right here, base. I'm just going to stick with that. You'll notice too that there are several other options. You've got from an Excel file, SPSS, SAS, and Stata file, but we're going to stick with from text right here. And here is our data set on my computer. So I'm going to click on Open, and here's our little import wizard, if you will. We'll scroll down and we'll press Import, and there you go. So as you're looking at this, just notice that there's some code right here. It says read.delim. This is basically the command that the RStudio is using to read the data into a new object in RStudio, and that's our object right here. So this is actually containing our data set. So this right here is actually built off kind of the name of the original file that we were importing. So just keep in mind that so what's going to happen is, as we are running our analyses, we're going to have to refer to this data set and the variables within this data set. But so that's just kind of part of the process. And if you want to get an idea about what the data, how it's structured and so forth, you can use the str function, and what we'll do is we will use this object name right here. I'm going to copy that and put it inside the parenthesis here and hit enter, and you can see that we have a data frame, and you can see that our variables are basically numeric or integer. So we're good to go for carrying out our analysis. So now let's go ahead and begin with our process syntax. So the first thing that we're going to do is we're going to type in process, and inside the parenthesis we're going to type in data equals, and then we are going to refer to that data frame, which is this right here, the September period 2021 or 2021 period regression period data set right there. So it's a long name. A lot of times what I will do, by the way, is I will just save a long name like that to a new data frame object name, if you will, just to kind of make things a little less cumbersome when you are typing in your code. So next what we will do is we'll type in a comma, and we will type in y equals, and then the name of the outcome variable. But we need to make sure that this is in quotation marks. So I will type in achieve right here inside quotation marks. Then we will type in x equals, and then the name of our x variable, which in this case is interest. And then we will add another comma, and then we will type in m equals, and inside the quotation marks the name of our mediator variable. So that is engage. Now as you're typing, make sure that first the variable names are in quotation marks. Second, make sure that they are in the correct case as they appear in the data set. So you cannot kind of mix and match capital letters and lowercase letters. You can't do anything like that. You need to make sure that everything in terms of the variable names matches what is in our data frame. Next, we are going to indicate our model. So I'm going to type in comma, and then I'm going to type in model equals 4. So that's the model number that we're working with for our simple regression analysis. If I type in comma and then describe and set that equal to 1, that will get me descriptive stats and correlations for my variables. And then finally, if I type a comma and then stand equals 1, that will get me standardized regression coefficients. So now we're ready to go. I'll press the enter button, and you can see that now we are generating our results. Notice that it takes a few seconds. There's a little stop sign up here, and you can see down at the bottom there was a little thing that was it said bootstrapping progress. By default, the macro was generating 5,000 bootstrap samples or resamples in order to compute the confidence interval for our indirect effect. So it took a couple of seconds in order to make that happen. But let's go ahead and take a look at our output. So if we scroll up at the top, you can see that we get our model number, which is model 4. We get our y, x, and m variables shown right here. The sample size, the total effective sample size was 70. You can see that we have our variable means and standard deviations that are shown, variable intercorrelations that are shown right here. So you have a number of just basic descriptive stats that are provided for you. When we scroll down a little bit further, you can see that we have our first regression model, that simple linear regression, where we regress the proposed mediator of engagement onto the interest variable. So the R-square value is 0.1519, the multiple R is 0.3897. You can see that the significance test for the overall model is well, the f-test here, and we have statistical significance. So we would infer that the population R-square is greater than 0 based on our p-value of 0.0009 being greater than the conventional alpha level. Then we have in this model table right here, we have the intercept for the model, which is denoted in this constant row right here, and then we have our predictor, which is the interest variable. So this is our intercept for the model, this is our regression coefficient for the model. You can see that we have a t-value and p-value that's printed out, as well as a 95% confidence interval right here. So based on just this output right here, we see that interest is a positive predictor of engagement, and we see that we have that's statistically significant. You can also see that underneath we have the standardized coefficients that are given, and we only have this standardized regression slope for the interest variable that's provided. So next we'll scroll down, and you can see the outcome variable for our second model is achieve. So that was regressed onto interest and engagement. So as you're looking at here, you can see the R-square value for this model was 0.3727. Our f-test is indicating statistical significance. So we would infer that the population R-square is greater than 0. For our model coefficients, again, we have our intercept that's given right here. We have the regression slope for interest predicting the achievement variable. So this is our C prime path, if you will, and you can see that that path is statistically significant, and you can see that with the engagement, the path from engagement to achievement is also positive and statistically significant. So you notice that basically this right up here, the first model, that path coefficient is our path A. In the second model, our path coefficient from engagement to achievement, that is our path B. Then we have our standardized regression coefficients that are given for interest and engagement in that second model. When we scroll down a little bit further, you can see a little bit more detail. You've got the direct effect of x on y, which is basically going to be the same thing as what we have in the second model. So you can see that that there's our interest slope, our t-value and p-value that's given right there. That's kind of restated down here in this part. So then our main thing that we're interested in when we're testing for mediation is the indirect effect of our x variable on y by way of the mediator. So you can see right here our mediator was engagement. This is the computed indirect effect by multiplying the path coefficients for that simple regression and from that second regression. So our path A and B. Next you can see that we have a bootstrap standard error given, and then we have a bootstrap 90, basically the upper and lower bounds of a bootstrap 95% confidence interval. That's the default. You can make a change in SPSS, not SPSS, excuse me, in R if you want. There is some code in that Appendix A that would allow you to make a change to the confidence interval if you wanted. So if you wanted like a 99 or 90% or something like that. But the default is for a 95% confidence interval. You also see below, because we had requested those standardized estimates, we do get a completely standardized indirect effect. So this is the standardized indirect effect. It would be computed by multiplying those standardized regression coefficients for A and B paths respectively. And so here's our confidence interval. So as you're looking at really both of these, you can see that we'll just go back to the unstandardized coefficient right here, and you can see that this is positive. So in a nutshell, what that's indicating is that the indirect effect of interest on achievement by way of the mediator engagement is positive, and because 0, which is the null, basically, because 0 does not fall between the lower and the upper bound of that confidence interval, then we would deem that effect to be significant. So that's basically how you would interpret our indirect effects right there. And the same basic principles would apply if you wanted to focus in on the standardized indirect effect of x on y. So let's say, for argument's sake, that you wanted to include covariates in your model. Well, you can certainly do that. So I'm going to just show you, we're going to add in this gender ID variable right here as a covariate within our model. So what we'll do is, I'm not going to type all this stuff in directly, I'll just kind of paste it in right here. But you can see that we've got, again, our code process. We have the data argument set equal to the name of our data frame right here. We've got y equals achieve, x equals interest, and m equals engagement. All of those are the variable names are in quotation marks, followed by now a comma, and then we have another argument which is cov, C-O-V, and that's all in lowercase, set equal to, and then we have C, and inside a parenthesis we've got the covariate name, gender ID, and that's inside quotation marks. So when you're working with R, what this is using is a list function. So you'll notice, again, we have cov equals, but the list function is the C right here. And so anything inside of the parenthesis is going to be treated as a list, in this case of variable names. So you can see that we've got gender ID inside quotation marks. If we had another covariate, let's just say for argument's sake that we wanted to include efficacy. Let's say efficacy was another variable that was in our data set. It's not, but let's just assume. Then I would include a comma followed by quotation marks, efficacy, and end quotation marks, and then we round it out with the end parenthesis right there. So we don't have that, so we're just going to leave that out. But that's basically how you can add in more than a single covariate within your model. So at this point, we'll kind of remove that efficacy variable and we'll run our analysis. So I'll go ahead and press enter, and again, it takes a few seconds to go through those the bootstrapping process, but once it's done, that little stop sign right there will go away. And so now when we kind of scroll back up, you can see in terms of our variables, we've added in gender ID as a covariate right here. we've got, again, because we left in the describe argument, set that equal to 1, we get our variable name, variable mean, standard deviations, intercorrelations. When we scroll down to that first regression model, our output, we've got engagement regressed onto now both interest, our x variable, and the covariate right here. And so you can see we have our regression slope for the covariate and our p-value. You can see that the covariate was not a significant predictor of the mediator in this particular model. Interest still sticks in there as a positive and significant predictor. When we scroll down, you can see with achievement, we have, again, gender ID has been included as a covariate, and it's still not significant. Again, here's our x variable with its regression slope. And here's our mediator variable with its regression slope. You can see that the standardized coefficients were printed out for both models, and basically all of our computations of the indirect effects are provided as well, along with the bootstrap. Well, the indirect effect was computed along with the bootstrap confidence intervals. So really there's not a whole lot of change in how you do things. It's just that now if you're going to add in covariates, you have to add in that cov argument, and then just kind of list out the covariates. So that basically wraps up this demonstration, and I appreciate you watching.